Hey guys, so I got called out today because my daughter was sick. I had to go pick her up from daycare and take her to the hospital. She's just down having a nap right now, so I figured I'd try and throw together a quick video here to do a quick lesson for you guys. So we're looking at 5.3 solution concentration. So we're going to be looking at different ways that we express concentrations of solutions over the next few days. So first of all, just a quick definition of concentration. So a concentration is a ratio of quantity of the solute to the quantity of the solution or solvent. So we're looking at salt being dissolved in water and how we can express those various forms of concentration. Now, concentration can have a tremendous range. We could have a very dilute solution, so taking, just a pinch of salt and putting it in a cup of water, or taking, a big heaping spoonful and putting that in a cup of water. Those would have a large difference in concentrations. And so because concentrations have such a wide range, there are many ways that we can state concentration. One of the main ways that we're going to be looking at today is expressing concentration as a percent. And so when we express concentration as a percent, we write the quantity of solute over the quantity of a solution. And this would be, I think, one of the first blanks you have to fill out on that in your note package. Okay, so a few different ways that we can express concentration as a percentage is by mass. So we're looking at percentage weight per weight. Or we can look at concentration by volume when I look at either the concentration of a volume of a solute over the volume of a solution. We can also look at this as if this was the mass of a solute in the volume of a solution. That's what we're going to be looking at for the first part of today. Then we'll come back and we'll look at parts per million. So I'll come back to these slides here. So looking at concentration as a percentage. So here's an example. A photographic stop bath contains 140 milliliters of pure acetic acid in a 500 milliliter bottle of solution. What is the percentage by volume concentration of acetic acid? Now the nice part about working with these percent concentration solution formulas is generally we don't have to change the units from the units that are given. As long as the percentage is less than 100, I should more or less just be able to take the numbers that they give me and put it into my formula. So the formula I can use for this is I'm looking for the concentration percent volume per volume. So, and that's just based off of here, percentage by volume. So I know I'm using this formula, so I take the volume of the solute over the volume of the solvent. Now the volume of the solute is this 140 milliliters of acetic acid, so that would go on the top. And then on the bottom is the 500 milliliter bottle of solution. So this is the total bottle, and in that 500 milliliters, there's 140 milliliters of acetic acid. So I substitute those numbers into my formula accordingly, and then all I need to do is take this and put it on my calculator. So 140 milliliters divided by 500 milliliters would give me 20.28, and then I would divide that by 100%, and so that gives me 28.0, looking at sig digs here, and percent volume per volume because both of these were solutions. Okay, next example is if 5 grams of salt is mixed with 50 grams of water, what is the percent by mass? So now I have to use the different formula here because I'm looking at the mass of the solute over the mass of the solution. So the mass of the solute here, that's that 5 grams of salt. It's being dissolved in 50 grams of water. But because we're looking at mass here, and this isn't the total mass, we have to add both of these together to get the total mass of the solution. Because if I add 5 grams of salt to my 50 grams, well, it's no longer 50 grams. That thing would weigh 55 grams. So I'll put those numbers into my formula accordingly. 5 grams for the mass of the solute, and then 55 grams for the mass of the solution. Put that all into my calculator. I should get 9.1%, and this would be weight, and you have to express what's happening here, because 9.1% doesn't really tell me much. It's weight per weight. I need to include those units in there. And it's weight per weight because this is expressed in grams, and like the numerator and denominator are both expressed in grams, so it's weight. Okay, the next example. So how many grams of fat are in a 90 gram serving of cereal if the percent is 15%? If the percent by mass is 15%, sorry. So this question works a little differently. Now we're actually given the percent and we need to figure out something about the formula. Now this is probably going to be pretty bad because I have to click with my finger, but we'll see how it goes. So I know this is a 15% weight per weight. So that would equal the mass of the solute over the mass of the solution. But from this example, how many grams of fat are in a 90-gram serving of cereal? So I'm looking for the mass of the solute. Ooh, this is really bad. I know the mass of the solution, which is the total serving. It's that 90 grams. So all I need to do here to solve for the mass of the solute is cross multiply and divide. But remember, we never actually deal with percentages. They're just a way of representing something. So I have to take this 15 and divide it by 100 to get a decimal, which is something I can work more with. So 0.15 equals, I'm just going to leave this as an M of S because I don't want to spell out solute again, over 90 grams. And so to rearrange here, all I need to do, technically this is over 1, so I could cross multiply and dividing by 1, which does nothing. So 0.15 divided by 90, I gotta get out my calculator, 0.15 times 90 gives me the mass, which is 13.5, and so I would look at sig digs, it's 2 sig digs, I'm gonna round that up to, there would be 14 grams of fat in my 90-gram serving of cereal, assuming that it's 15% mass, 15% by mass. There's the other version. Okay. So that gives us a summary looking at the percent questions of solutions. Again, remember when you're dealing with any of these type of questions for percentage concentration, you never have a percent that goes over 100%. If that's the case, then you need to change the units, but most of the time, or majority of the time, the questions should give you units that you can just plop into the formula and you'll get a percentage that works. So the next thing we're going to look at here, after looking at these percentage concentrations, is expressing concentration in parts per million. And so when you're in biology, you know, and you're talking about the concentration of oxygen dissolved in a lake, I talked about this a few days ago, we always express that in parts per million. And so what parts per million is saying is if there was 1 million particles, how many of those particles would be blank? So for example, if it was 8 parts per million oxygen, well, out of 1 million water particles, 8 of those would be oxygen. As well as swimming pools, when they talk about chlorine or impurities in a lab, they also express concentration in parts per million. So what we really need to know here is this right here, and you should write this down, that 1 part per million is equivalent to 1 gram per 10 to the 6 milliliters, which is equivalent to 1 milligram per liter, or 1 milligram per kilogram. And those end up working out if you look at them in terms of mathematically. Each of these is separated by 1 million, or 6 zeros. So we can take these, and these more or less kind of give us a formula to help us figure out things in parts per million. So that means if I was to have grams, I'd have to have my other units in milliliters. If I had milligrams, I'd have to have my other units in liters. Or if I had milligrams, my other unit would have to be kilograms, because each of those are equivalent to parts per million. So if we go to example number 4 here, it says that dissolved oxygen in natural waters is an important measure of the health of an ecosystem. In a chemical analysis of 250 milliliters of water at SATP, 2.2 milligrams of oxygen was measured. What is the concentration in parts per million? So if I remember this, well, 1 part per million is equivalent to 1 milligram per, oops, what the heck happened there? Per liter. And this is the one I really like to deal with, not with the milliliters. So 1 milligram per liter. So all I need to do is change the things on here to match this. So milligrams, I have 2.2 milligrams, so I don't need to change that at all. So this would be 2.2 milligrams per, what the heck? Milligrams per liter. Now I have to change this 250 milliliters to liters by dividing by 1,000. So that would move this decimal 1, 2, 3 places. So 250 milliliters is equivalent to 0.250 liters. And then all I need to do is divide these numbers. So 2.2, excuse me, 2.2 divided by 0.250 gives me 8.8. 8.8, that's brutal, milligrams per liter. And now that I have this units as milligrams per liter, well, technically I can say that that is equivalent to 8 parts per million. So a big thing to remember for these parts per million questions is you have to make sure you're using units that are appropriate to convert to these parts per million. Also, you're not given these conversions on the test. These are something you have to memorize. These two are the one that I usually choose to memorize because you can get to this without, like, you can go from grams to milligrams, liters, so it's just one less formula to memorize. So quickly look at number 5 here. So, oh, I already have stuff on there. Okay, so water hardness is a measure of the calcium ion concentration. The hardness of Calgary's water is rated at 165 parts per million. What mass of calcium ions is found in 1 cubic meter, which is 1,000 kilograms of Calgary's water? So this 165 parts per million is saying that in the a million water, or out of a million, 165 of those particles are calcium ions. So what we can do is figure out, well, 1 part per million is equivalent to either 1 milligram per kilogram or 1 milligram per liter. Now, because this question is asking me for the mass of calcium ions, and they give me a mass here, I'm going to assume that I'm using the units for 1 milligram per kilogram. Oops, 1 milligram per kilogram. And I'll take everything that they give me in the question and put it in here. Now, because they give me concentration, I kind of have to work backwards. So I know the concentration is 165, so that's going to go on the left side here. ppm over milligrams per kilogram. Well, this is what we're looking for, the numerator, which is the mass of the calcium ions. So I put a X milligrams up top over the total of what we're looking for, which is that water, which is that 1,000 kilograms of water, and they already gave that to me. So 1,000 kilograms, really nice question because I don't even have to actually convert units. So I need to solve for X. So technically, remember, this is over 1, so I can cross multiply these two numbers and divide by the odd number out, which isn't going to do anything. So 165 times by 1,000 is X would equal 165,000 milligrams. I could change that to 1 point, how many sig digs are here? 3. I could change this to 1.65 times 10 to the 4 milligrams, or, so 1.65 times 10 to the 4 milligrams, or it's 165 grams, because I just divide this by 1,000, and that would give me to go from milligrams to grams. Okay, that's everything. You're gonna look at question questions 1 to 9 in your homework booklet for homework 3. Questions 1 to 9. Hopefully this helps, guys.